Okay, so for number 21, let's see, they have 5 doors, and 2 of them have cars, and there are 5 total, and we're choosing 2 doors. And we want to choose at least 1 car. So when you see the at least 1, you're thinking not none. So what we're going to do is we're going to find the probability of getting 1 car and do 1 minus, like at least 1 is 1 minus the probability of all not cars. So if we want the probability of getting no cars, there are 3 that are not cars. So 3 not cars, and we want to choose 2 of them out of 5 cars total, and we're choosing 2 of them. So there are 3, and this would be the probability of getting no car. Right? This is the probability of getting no car. There are 3 doors that don't have a car, and we would choose both of those. And there are 5 doors possible, and we're choosing 2 of those. But of course, we want at least 1 car, so this is what we don't want. So we'll take 1 minus that. And that's the setup. If you want at least 1, you find the probability of getting none and do 1 minus that. So these you figure out just like you figured out stuff before. So we're going to come over here, we're going to do 3 choose 2, 3 factorial over 1 factorial times 2 factorial. So 3 factorial, so 3 times 2 factorial over 1 times 2 factorial. So those cancel, and you just get a 3. And then 5c2 is 5 factorial over 3 factorial times 2 factorial. So 5 times 4, let the 3 factorial cancel. 2 times 1, cross that out, you get 2, so here you're getting 10. So plugging this in, we're going to get 1 minus 3 over 10, and just grabbing a common denominator, 1 is like 10 tenths, minus 3 tenths, so we get 7 tenths. Lucky us. Yep, 21 7 tenths. 25. Let's see, so we have 10 pitchers, 6 infielders, and 9 others, for a grand total of 25. And what we want 2 pitchers and 1 infield. So to choose our 2 pitchers, there are 10 pitchers total, and we want to choose 2 of them. And to choose our infielders, there are 6 infielders total, and you want to choose 1 of those. We want this and that. So when you see that and, you're thinking multiply. So if there are this times that, many ways to choose your 2 pitchers and your 1 infielder. So to make this a probability, you divide it by the total number of ways to choose 3 people. So you have 25 people possible to choose from, and 2 plus 1. So 3 people that you're choosing total. So this setup is going to give you your probability, and you would work out each one of these using the formula or the calculator. And I'm just going to punch them in on the calculator because I think you've seen most of these before. So 10c2 is 45, 6C1, 6, and 25C3 will give you 2300. So 45 times 6 is 270 over 2300, and if we simplify that, we get 27 over 230. And that's that probability. Yep, looks good. So for 29, see, they have 10 mid-sized, 15 compact, and we're choosing, in this case we want to choose 3 mid-size and 3 compact. So again, we have 10 mid-size cars and we want to choose 3 of them. We have 15 compact cars and we want to choose 3 of them. We want to choose the mid-size and the compact, so we're going to multiply the number of ways to do those together. And to make it a probability, we're going to divide by the number of ways to choose 6 cars. So there are 25 cars total, and we're choosing 6 of them. So again, got our setup. I'm just going to punch them in on the calculator. 10C6, oops, sorry. 10C3 is giving you 120. 15C3 is giving you 455. And 25C6 is giving me 177100. So if I do 120 times 455, I get 54600 divided by 177100. And if you simplify that fraction, 54600 divided by 177100, you get 78 over 253. That should be good. Oh, and they just divide that. So 78 divided by 253 gives you 0.3083. So if you don't feel like simplifying this fraction, you can just do 5/4 this divided by that, and you should get this answer. Excellent. And for 33, let's see, 12 routes, 4 in Florida, 5 in California, 3 in Texas. And so for a grand total of 12. And what we want to choose is we want 1 in Florida, 1 in California, and 2 in Texas. So there are 4 routes in Florida. We want to choose 1 of them. 5 routes in California, and we want to choose 1 of them. 3 routes in Texas, and we want to choose 2 of those. We want this and that, so we'll multiply those all together. And to make it a probability, there are 12 possible routes, and we're choosing 1, 2, 3, 4. So 12 choose 4 possible ways to choose 4 routes. So plugging these all in, this would give you 4, that would give you 5, this would give you 3, and this would give you So 4 times 5 times 3 is 60 over 495. Let's see if they give that as a decimal. Nope, they just simplify it. So they do 60 divided by 495. If you simplify that fraction, you get 4 out of 33. There we go. And let's see. So 37, 5 men and 6 women. So 5 men, 6 women, 11 total. And we're choosing let's see. So we want exactly 1 woman in the first 5 seats. So we want to choose exactly 1 woman in the first 5 seats. So if we're choosing exactly 1 woman, if there are 5 seats that we're choosing for, when they say 1 woman, what we mean is exactly 1 woman and 4 men, right? So so it's implied that if you're choosing 5 and you have exactly 1 woman, then the rest are men. So now that we have that set up, we can see that there are 6 women and we want to choose 1 of those, 5 men and we want to choose 4 of those. We're going to multiply those together to get the total number of ways to choose 1 woman and 4 men. To make it a probability, we want the number of ways to choose 5 seats. There are 11 people total, and we want to choose 5 of them. So if we work these out, this 6C1 is 6, 5C4 is 5, 11C5 is 462. So we have 30 over 462, which simplifies to 5 out of 77. So 5, excellent. 41.